Hello students. Today as we continue to look at solving equations, we're skipping all the way to 2.8 and it's solve for a specific variable. Okay, so what I'm going to do in this is typically when we solve equations we have numbers with our variables and we find one variable equaling to one number. Well, sometimes we're given an equation that doesn't have any numbers, for instance like y equals mx plus b, and what they want us to do is solve for a specific variable. Right now this equation is solved for y. It's telling me exactly what y equals. But sometimes we want to figure out how to solve for another variable because we might be given different information in an equation. So for instance, let's say that I'm just going to solve for b. I want to solve for b. So what I need to do when I say solve for b is get b by itself. Well, right now b is being added to mx. And if I want to get b by itself, then I have to subtract mx from both sides. And so that cancels out, and I'm left with y minus mx equals b. Okay? So I just solved for b. So if I'm given a y value and an x value and a slope, then I can use this formula to find out what the y-intercept is, because that's what b stands for. Okay? But what if I'm given y equals mx plus b and I need to solve for m? Okay, so I'm going to write this above, solve for m. So think with me or watch my thinking process. I know that m is right here with the x. So I've got to get rid of this b and then I got to get rid of the x. Well, when we were doing normal equations, we would not start with the x because something's added or subtracted, so I have to get rid of the b first. So it's added to both sides, or added right now, so I have to subtract it from both sides. Minus b minus b. So I have y minus b equals mx. Now, I'm just doing my opposite operations like I always do. I've got mx and I need to get m by itself. So this is multiplication, and the opposite of multiplication is division. So I would divide both sides by x. Divide by x, divide by x. And there's my answer. Y minus b over x equals m, because those two x's cancel out. So I've solved this equation for m. M equals y minus b over x. I know it takes a lot to get your brain programmed to not having numbers in these equations, but that's okay. Just continue to do the opposite operation. And if you need to look at it and you need to replace everything with numbers so it helps you, you can do that, but we've got to learn to make sure that we also solve it without the numbers. Here's another example. In science, there's a formula for ohms that equals I equals V over R. And don't ask me what they mean because I don't know. I just have a formula. I equals V over R. And so now what I have to do is, let's say I'm going to solve the equation for V. So I need to solve this equation for V. Well, we got V over here with an R, and it's being divided. So what would I have to, what's the opposite of dividing? Yeah, it's multiplying. So what do I have to multiply by on both sides? The r, because I need to get rid of the r, so the v is by itself. So I'm going to simply multiply both sides by r, and r times I equals v. Okay? It's not a big, hairy, scary deal. It just takes some rethinking. The next example we're going to look at is 4r minus 3t equals 8. And in this case, they want me to solve for r. So I need to solve for r. So I'm going to look and see, where's r? Well, I've got minus 3t on the same side, so I've got to get rid of that. And then I'm going to have to divide by 4, but I have to go in a correct order. Okay? So first I'm going to get rid of the 3t by adding 3t to both sides. So that is 4r equals 8 plus 3t. Okay? So now I have to divide by 4 on both sides to get r by itself. So that leaves me with r equals 8 plus 3t over 4. That is a correct answer, but I could simplify it a little bit more by going r equals 8 over 4 plus 3t over 4. I can just separate the numerators over the same denominator, and now I can simplify. 8 over 4 is 2, so r equals 2 plus 3t over 4, or I could also write that as just 3/4 t. Both of those are the same, and you'll see them in both ways depending on where you get the information from, okay? So again, I figured out what I needed to solve for, and then I used the steps to get rid of everything else, so I ended up with just r. And in this case, r equals 2 plus 3/4 t. And so here's the last example I want to show you, and it's d plus 5c equals 3d minus 1. And what the instructions are telling me to do is to solve for d, okay? So let's evaluate. I've got a d, and then I've got 3d. I've got variables on both sides. So we need to go back to what we did the other day with variables on both sides, and we want to start with the smallest variable. So let's deal with that first, okay? So I've got a d and a 3d. The smallest d is the d, and so that's 1d. Have I told you that story why we don't put a 1 there? Oh, I should do that sometime. There's a d here, and so d plus 5c equals 3d minus 1. So I'm going to subtract d from both sides. That cancels out. I'm left with 5c equals 3d minus 1d is 2d minus 1. Okay, now I'm down to a two-step equation, but I'm solving for d. Okay, so I've got a 2d here, and I've got a negative 1, so I need to get rid of that negative 1 first. And so I'm going to add 1 to both sides. And those aren't like terms, so I just write it out as 5c plus 1 equals 2d. Okay, now to get the d by itself, I have to, divide by 2. And so the 2's cancel out on the right-hand side, and I'm left with my answer. 5c plus 1 over 2 equals d. Again, retraining our brains to think for a variable instead of, or when there's 2 variables instead of just 1. And here are our practice problems for this video. The first one says 3n plus 6p equals 15, and I want you to solve that for n. That means get n by itself. And the number 2 problem is k minus 2 over 5 equals 11j, and I want you to solve that one for k. So you got those 2 problems. Take a picture of your practice problems when you're finished and turn it into Edmodo. If you have any questions, email me.